All right. Hello, everyone. Hi, my name is Daniel Bock, CEO and co-founder of Morpheus Space. It seems like I'm competing with a lunch break, so nonetheless, I'm happy that you could make it. So Morpheus Space, we are a space company, as the name already indicates, and our mission is to make space mobility safe and simple. Before I jump right into it, I wanted to start with a short personal story as a background. So I was fascinated by the first space race in the 1960s and following on, and I kind of was sad when I grew up that I wasn't that old to basically experience and witness that for myself. But it was a great time where a lot of creativity, technology advancement, and so on happened. And yeah, it was all fueled by the Cold War in the end. But my sadness actually turned into excitement over the last 10 to 15 years because we are in the middle of a new space race. And this is happening not only on a geopolitical landscape, but also on the commercial landscape. And a lot is happening in space. And I'm super happy that the team and I are part of that. But what's different to the old space race? We are now heavily depending already on space-based services. So that ranges over many industries, many verticals. To just name a few, so agriculture, precision agriculture is a big topic. You can basically look from space down to Earth, increase the processes, having better yield for agriculture. Navigation, GPS, I think everyone is used today GPS to come here. Banking is heavily relying on the timestamp for making transactions, and many more. Connectivity to connect everyone on the world through space-based internet, and also our critical infrastructures and the military's weather forecasts, you name it, and disaster management all depend on space data already, and this is increasingly, drastically increasing. And you can see that with the numbers. So these are the numbers of satellites launched in the last decade and projections over the next decade, and that is quite a conservative projection actually. And until 2019, we basically, or from 2019 on, we basically launched more satellites per year than we launched over the last decades. So since the beginning of the space race in the 1950s. And alone Starlink, so the SpaceX constellation, launched this year 400 satellites. And this is drastically increasing, and it's not only SpaceX, there are other big constellation companies, OneWeb and others, and also other verticals are looking into space. The agriculture, I named it, the automotive industry to connect the cars, and many more. John Deere, for example, is another example, a partnership between SpaceX and John Deere, and T-Mobile and SpaceX. So space is growing, but this comes with three big major challenges. So space is getting more and more congested, it's getting more and more contested, and competitive. Congestion, what does that mean? So we have now over 1 million of particles, objects flying around. It's not just flying, it's shooting around our Earth with speeds of, faster than a bullet. And so they can create a lot of damage to any satellite if they are basically hitting that satellite. And alone Starlink is doing 140 collision avoidance maneuvers per day. And that's increasingly going up exponentially. On the geopolitical front, we are not only having contest between two main powers anymore, the US and the Soviet Union. Also new entrants are basically coming to the space race. For example, China, Russia, India. So it's a very contested space. The US Space Force Chief, General Saltzman, recently said, space is contested more than ever before. And militaries are investing huge amounts to stay ahead of that race. And on the commercial side, space is getting more and more competitive. So the launch costs dropped by 10x already, and another 10x to 100x are on the horizon with Starship. And this puts a lot of pressure on manufacturing and operation on the satellites where it didn't arrive yet. So these three main challenges basically are a fundamental question of space mobility. Why is that? First of all, congestions. If you need to avoid a maneuver and also apply with the recent regulations to deorbit satellites, you need to perform more maneuvers. So you need better, more efficient propulsion systems, and you need the means basically to perform these maneuvers. On the military side and defense side, you need to quickly escape any danger if any adversary is basically putting a threat on your assets. And you potentially also need to confront the adversaries in low Earth orbit. And last but not least, on the competitive side, you need to perform more maneuvers to, first of all, being competitive by extending your mission lifetimes and also by increasing the payload utilization and productivity. We are operating satellite constellations mostly, so that means it's a harmony of many satellites working together in a network, and maneuvers are key basically to make that productive. But there's a big but. Space mobility is extremely complex still. It's very expensive. It's unavailable, so we have also a big supply chain issue, and it's unreliable as well. Maneuvering is pretty hard to do in space, so it's not just putting an engine on a satellite. It's a lot of careful planning, analysis, and also execution. I don't want to go into the details of all these maneuvers here, but these are the main applications, and you can imagine that maneuvering in space, you need to consider a lot of analytics, and in the end, it doesn't mean if you put a propulsion system on a satellite that you're able to maneuver. On the other hand, I mentioned it's very expensive, so propulsion systems are still making 20 to 30% of the total cost of a satellite. So it's very expensive to put a propulsion system on a satellite, and most of the satellite manufacturers are not building them in-house because they're quite deep tech developments that they cannot just put in-house, and most of the propulsion systems are not scaled from the production side. So this is why these high costs come into play. And if you have the money, then you're still waiting over a year to acquire basically a propulsion system. And missions are on hold, and launchers are not going up because propulsion systems are not delivered. Last but not least, if you're lucky and you get a propulsion system, the biggest failure reason for any mission is basically a failure of propulsion systems. So we have also a huge reliability issue for propulsion systems. And our mission is basically to completely change that. We are making space mobility safe and simple. And we are doing that by an holistic approach of software and hardware. So first, we provide a subscription-based web platform where you can plan and control your missions. So you're simulating the orbits, you are basically getting a list of maneuvers that you need to perform. And we also put in a marketplace where you can match the requirements of your mission with a list of more than 330 subsystem providers, so not only propulsion. And so we are also addressing the supply chain issues for the broader industry. The second is our propulsion systems. So we are developing and producing highly efficient electric propulsion systems. And I have one here with me. So it's a very compact, all-including propulsion system, electrical based. So we are using metal as propellant. And it's highly reliable. You see 40 exhausts here. So you can individually control them. It's designed for manufacturing, and we're just in the process of opening up a new production facility in Dresden to build hundreds of these satellites, having hundreds of these propulsion systems, having them basically on stock and solving that big supply chain issue. And last but not least, it's not about only planning and executing, it's also about autonomy. So with all these collision avoidance maneuvers, with these tens of thousands and maybe hundreds of thousands satellites in space pretty soon, we need to get autonomy on board of these satellites. So we are also developing an autopilot, which you can imagine as a self-flying satellite that can execute maneuvers autonomously. It's similar like Google Maps. You basically get recommendations how and when you need to maneuver to avoid a collision or to get to the orbit that you need to. Space mobility is a massive opportunity. So with these 3 products, we are basically addressing a multi-billion dollar market that is growing drastically. On the one side, the propulsion market that is underutilized with the supply chain issue, the software market on automatizing mission maneuvers and analysis, and the autopilot market is a greenfield market, so there's basically no one offering an autonomy solution so far. This is showing like our trajectory over the last years. So we founded our company in Germany, Dresden, and in 2018, quickly expanded to the US. So we participated in the very first Texas Space Accelerator in Los Angeles, and that was basically the ignition point for us to expand to the US. We flipped the company pretty early in 2019, raised about more than $30 million so far. Opened up our US office in Los Angeles, launched our first commercial products, our first generation propulsion system with dozens delivered and 1 in space already operating right now. And we have now dozens of multi-fields in space, as I said, and it's all about this year about scaling. So scaling on the product side. These 3 products are coming or came already to market. We have our grand opening of our mass production facility, delivering soon hundreds of propulsion systems, and it's about scaling the business, of course. That's only possible with a stellar team. So we have great investors. One of them is here as well, V2 Ventures. Thanks for coming up. Airbus Ventures, also national security, strategic investors from Incutel, for example, and Palace Ventures, Lavrock Ventures. And we are on a great journey. We are not actively fundraising at the moment, but we are happy to connect, and I'm happy to discuss more what you're doing. Thank you very much.